In this video, I would like to talk some more about my current project of trying to write a computer program which will in turn generate music. More specifically, I'd like to talk about the two pieces of software that I intend to use, and I would like to talk a little bit about representing musical pitch in the form of numbers. So let's start with the two bits of software that I'm going to use. They're both on the screen here. They're both free programs, and I'm going to provide a link to both of them. So if you want to download one or both, in the description of this video and in the description of videos to come. On the right, we have MuseScore. On the left, we have Twine. MuseScore is a program for notating music in what I would call the traditional format. This is the same format that you would find in sheet music, where we have a conventional set of symbols that represent duration. We use the vertical dimension to represent pitch, so that I have a note here, and if I make it a higher note, it also sort of becomes physically higher on the page, and similarly if I make it lower, it also goes physically lower on the page. And this is read in the same order that we would use to read English language writing, which is to say we would start in the top left-hand corner, we would read across like this. When we come to the end of a section, we go down here. If the score continued, we would continue to do that, and perhaps it would be divided into pages, so we'd turn over the page. Obviously, there's a great deal more to writing sheet music than what I've just told you, but I will sort of get into that as we go through it. The other piece of software, the one where we're probably going to spend most of our time in these videos, and certainly the place where I'm going to spend most of my time doing the writing of the program, is Twine. Twine is it's not really meant for what I'm using it for. It was actually invented to allow people to write sort of choose your own adventure type stories that could be shared on the internet. But the version of Twine that I'm using has added a lot of sort of programming capacity, so it's pretty much become a full programming language. Now you might say, well, why pick something that's not designed for this? Why not just use a general programming language? You might have heard of C, for example, or Perl or Python. These are all common ones. And the answer is simply that I've been using Twine for quite a long time, and so I'm familiar with a lot of the operations and how to do particular things in Twine. I don't think it's the best choice objectively, sort of thing, for anyone, but I do think it's it's fine for what I want to do. It's probably going to work for me, and I'm used to it. So let's X out of that. No, actually, let's not. Sorry, I've made a little mistake about what I do. Sorry, let's talk about representing notes as numbers. So I have a representation of a note here. This is the note that's often called middle C. The reason it's called middle C is because if you're using a treble clef, which is this thing here, which indicates that we're dealing with fairly high notes, it's right down the bottom of that clef. But if we were over here using a bass clef, which tells us that we're dealing with bass notes, it would be right up the top. So I'll show you how you do it. That's actually the same pitch. So it's sort of in the middle if you're using these conventional clefs, which is what these symbols are called, and that's why it's called middle C. If I change it, if I move it up and down, I'm pressing the arrow keys to make that happen. You might notice it's a little bit difficult to see, so you might want to maximize the screen here. But down here, the the text is changing. So right now it says this is E3, and then if I go up, it says F3, F sharp 3, G3, G sharp, A sharp, B, and suddenly it says C4 instead of 3. And if I kept going up, it would change in a similar way. It would also do that if the note was up here. So what it's using is one system of naming notes, or naming the pitch of notes, where you have firstly a letter, and then possibly an accidental, which means a note, an indication that it's sharper, which means higher in pitch, or flatter, which means lower in pitch than the note indicated by the letter, and then you have a number. So what does that mean? How does that work? Well, you've probably heard of notes being like A, B, C, D, E, F, G. That is a sort of centuries-long tradition of the way that we name notes. For historical reasons, it doesn't start with A and go up to G, which is what you would, of course, expect. It starts with C. So it's we usually think of it as being from one C to another C. So we usually think of it as going C, D, E, F, G, A, B, and then another C. And that's how these octaves work. Let's get back to that. So here, so here's C3, up to G3, A, B, and then C4. So it divides the octaves from C to C. What an accidental is, you probably noticed that some of these notes weren't just given a letter, but they were something like C, and then there's a little hash, like a hashtag symbol. That symbol means sharp. The reason for that is because C, D, E, F, G, A, B aren't the only notes we use. We do use notes called C, D, E, F, G, A, and B, but we have 5 more notes that are sort of in the middle of those. So if I go, for example, from C to D, that's not one note but 2. There's C, then there's a note in the middle, and then there's D. And we can call that note C sharp, meaning it's one note, one semitone, which is the smallest value of notes that we use in sort of conventional Western music. We can call that C sharp, meaning sort of one higher than C. We can call the same pitch D flat, meaning one lower than D. And there are similar sort of gaps in between most of the letters. So between C and D there is, between D and E, not between E and F. E goes straight to F. Between F and G, G and A and B, and then not between B and C. And the reason, why do we have sort of gaps between some and not others? That's a somewhat complicated question, but the main answer is that we divide a section of these pitches into 12 equally spaced tones, but for most music, for most conventional Western music, again, we don't use all 12 of those notes. We usually use a selection of them, most often 7 out of the 12, and we call that selection a scale. And the most common sort of scale in Western music is the major scale, and it's set up so that the C major scale only uses notes that don't have any accidentals. In other words, the C major scale only uses C, D, E, F, G, A, and B. Other scales will have some notes that are written with a sharp and some notes that are written with a flat. But The reason why some notes have that sharp symbol after them and some have the flat symbol after them, the reason we don't just use 12 different letters for the notes is because of this convention of playing music in a given scale, meaning a given selection of notes. Again, that's a very simple, overly simple explanation, but this is not a music theory channel. This is a channel about my project of computer programming. So let's move on to computer programming. We have this convention that I talked about, A1, B1, C2, D5, etc., etc. If I wrote that down and sent it to someone who also knew the convention, they would know exactly what pitch I was talking about. And of course, this makes it easier to communicate when you're talking about music. But computers deal best with data when it's in the form of a numeric value, right? We can certainly give computers data in the form of text, and we often do, but even then they will generally sort of turn it into numerical data in order to store it or manipulate it. And certainly if we're going to be dealing with music, to deal with the most basic sort of concepts of music, we really need to think of notes as being numbers. So, of course, I could just make up a convention. I don't need to, this is for my own use. I don't need to sort of be make this communicable to anyone else. I could just say, all right, well, that note there, D4, I'm going to call that note 0. And then the next one up, I'll call it note 1, note 2, note 3, note 4. And then anything below that, I'll call it -1, -2, -3, -4, etc. Or whatever, right? I could pick any note as the basis. I could use whatever numbers I want. But there is already a convention for this. And the reason there's a convention for this is because of MIDI files. And what are MIDI files? Well, when you have a musical program, let's say that I'd written more music than just sort of one note. I'd written a whole score. I think it's great. I want to send it to someone else who's a musician. I want them, they might want to play it live, or they might want to put it on their computer. And I'm using MuseScore. Well, I could save it in MuseScore's special file system. MuseScore has its own files. I can't remember what they're called, but then what if my friend doesn't have MuseScore? What if he's got a synthesizer or something, and that uses its own convention for saving music? Well, that the MIDI format is sort of designed to allow different, originally probably mostly electronic synthesizers, but over time also home computers like this one, to communicate with each other, to send scores to each other. And it reduces music to a set of numbers, one set of numbers representing note duration, another set of numbers representing pitch. There's a bit more to it than that, but that's most of what it does. And so there's a sort of standard conversion. There's a standard conversion from the convention that we're seeing here, where that's A3, to turning that into a given number. And that convention is represented in this graphic. So we have the frequency of a note in hertz here, which we don't need to really worry about. We have the note name in the way that I've been talking about. At this range represents the range of a grand piano, basically. You can get -1 and lower, and you can get higher than 8, but this particular range is the one that we will mostly be dealing with. It's the range of a grand piano, as I said, and almost all other instruments their range is some subset of this as well. So it's most of the music you'll hear will be in between this note. I don't mean just on this channel. I mean most of the music you'll hear in your life will be, if not all of it, will be in the range of this note to this note up here. So we have the note name version, the version where we've got a letter and a number. They haven't got the ones with accidentals there because it'd be too crowded, I think. And then we have the numbers in MIDI. So for example, C4, which is middle C, it's also called middle C, has the number 60. And of course all the other numbers go from there. The one that's one semitone higher than 60, well, of course, that's 61. In sort of more old-fashioned notation, it's C sharp 4 or D flat 4, 62, 63. And as the notes get lower, well, the numbers get lower as well. And that it does make it is slightly arbitrary in the sense that you'd think that sort of you'd think it'd start at either 0 or 1, but it doesn't. It starts at 21 and goes to 108. So there's no sort of, like, it's not sort of obvious why it starts there and ends there. I know MIDI is capable of 128 different pitches, but I don't know why they chose a range, why they chose this particular range. I'm not completely sure. It might be, actually, now that I think about it, I think there'd be 20 numbers that are lower than the grand piano, and there'd be 20 numbers higher than that, wouldn't there, if there's 128? So, all right, there you go. I figured it out live. It's sort of centered on the range of a grand piano, but has a greater range than that. So there you go. Now you know. So if we've got these two conventions, we've got the MIDI number, which is sort of an easier way for computer programs to look at music, and we've got this note name, which is an easier way for humans really to deal with notes. If I said, oh, note 83, then 65, then 72, that's a bit hard to think about what that means. Whereas if I say, well, it's C sharp 6 and then F3 and then the other one, at least if you sort of know a little bit about music, you'd have an instinctive feeling of, oh yeah, that's what it is. So therefore, we might want to convert between them. And that's what I'm going to show you to end this video. This is an example of the kind of program that I'll be creating as we go through this series. Oops. Although this is very, very simple. This is just a program that picks a random note within the range of a grand piano, and then converts it from that number form, that MIDI form, into the letter and letter, possibly accidental, and number form, which is sort of easier for humans to look at. Now, I'm sort of undecided about how much detail I'm going to go into about the code. I'll go through this one line by line, but I'm not sort of sure whether I'm going to do that in every video. I mean, let me know what you want apart from anything else. But when we get to more complicated things, I might not explain every line. I might just say what the program does, unless of course people do want more detail. But anyway, what we have here is the program essentially stores the names of the 12 notes in what we call an octave. At the moment, we don't need to worry about what the physical basis of an octave is, but just so you know, notes go sort of C, C sharp, D, D sharp, E, and then back to C. So a single sort of set of these names covers a distance in music called an octave. Now, you might notice that these are all sharps, and I've said that you could use sharps or flats. Usually instead of a flat symbol, we just use a lowercase b when we're dealing with computers. I'm sure there is a special way of getting that the flat symbol, which is a little bit different, but for our purposes, it's probably not necessary. This picks a random note, as I said. That's what random means. Random 21, 108 just means pick a random whole number. The lowest you can pick is 21, the highest is 108. And then we need to divide it into the letter and possibly accidental part and the number part. And the way we do that is we set octave equals math.floor note value over 12 minus 1. So what does that mean? Well, note value is the name of the number that we've picked. This is called a variable. What we do is we give sort of names to the different bits of data that we're manipulating in a computer program, and that way whenever we refer to, for example, $note_value, the computer knows it's okay, whatever number is stored in this particular or is associated with this particular name, just use that. So we divide the value by 12 because there's 12 notes in an octave. Math.floor just means round down. And then we subtract 1. So as an example, let's say we picked 50. We would divide 50 by 12, which would give us 4 and a bit. We would round that down to 4 because this math.floor tells us to round down to the nearest whole number. And then we would subtract 1, and that would give us 3. So that gives us the one part of the answer. Then we do this, which means find the remainder when something is divided. Note value, it's sort of pronounced note value mod 12 would be the usual way of saying what I've written there. What that means is divide it by 12, but don't look at the answer you get, look at the remainder. So if, let's say we have 25, it would divide it by 12 to get 2 and a bit, but it wouldn't keep that 2. It would just keep the 1 that was the remainder when you divide it by 12, because 24 is 2 times 12. Once we've got that, we add 1 to that number, and then we look at that entry in this note name list. This list is called this type of list is called an array, but it's essentially a list. So we look in note name. Okay, but note name's a list. Which one of these do you want me to look at? Well, the number that I want you to look at, you can find by taking whatever value is in note_value, finding the remainder when you divide by 12, and then adding 1. And so we've got these we've got this piece of text here, which is might be something like D or G# or one of the ones that's in here. It won't be this one because I've put null there, you might notice. This is kind of, I don't know, this isn't really good practice, but these lists, computers start counting from 0, a bit counterintuitively. So a computer wouldn't say this was entry number 1 in the list. They'd say that was entry number 0, and they'd say this entry here, the text capital C, they'd say that's not entry number 2, that's entry number 1, i.e. it's the one that comes after entry 0. And I find that a bit counterintuitive, and so I prefer to just work from 1. I find it a lot easier in my head to think of 1 as being the first one. So I just put something in there to remind myself that we're not going to use it. I could just put an X or a dash or something like that, but I just put null, and it just reminds me, yeah, we're really only working with entry 1 up to entry 12. And then we just print meaning display on the screen, what we've got. So it says MIDI value, and then it'll say note. So MIDI value 54 is note, and then it'll print the data in note, which will be E, A, F sharp, or something like that. Then it'll print the data in octave, which will be a number, 3, 4, 0, and then it'll print a full stop. So if we run it, there's an example. MIDI value 67 is note G4. And if we look at that, oh no, we can't look at that website again. Sorry, hang on, I'll try and find it again. Yep, there we go. Sorry about that. Note 67. It's a little bit hard to line up, but yep, that is indeed, it is indeed G4. So it's doing the right thing. So that means that I can have the computer generate some notes as numbers, but then when it's and it can manipulate them as numbers, which computer programs find a lot easier, or is a lot easier to do with a computer program. But when it's finished, I can display the results as text, which is easier for me. And initially, I'm going to then put that text into MuseScore, turn it into music, sort of by hand. As the series goes on, I'll be generating longer and longer, I'll be generating more and more data, of course, working up to generating enough data for it to be a full piece of music. And it'll become less and less practical to do it by hand. So I'll have to look at, instead of just printing the results, instead of just displaying the results, it'll export it automatically as a file, which MuseScore can then read. So I'll just be loading the file into MuseScore rather than putting it in by hand. But for now, this is a useful thing. Right. So that's a little bit about the software we're using. It's also a little bit about the way that we're dealing with numbers and how representing pitch as numbers works. I've simplified everything that I've said. Everything that I've said is a really grossly simplified sort of explanation, but I'll get into everything in more detail as we go on. In the next video, I'm going to look at creating my first actual bit of music. I've sort of been setting everything up. In the next video, we'll be looking at creating an actual bit of music. It won't be it'll be far from a full piece, and it'll be a very simple little loop. But we'll actually be getting stuck into creating music, and we'll build up from that simple start. And we'll build up to sort of closer and closer to a real piece of music. But I'll leave it there for now. I hope that was useful or interesting to at least some of you, and I hope you will tune in next time.